IMO problem today, dated all the way back to 1960. What is that, 40, 80, 63 years ago? My goodness. Okay, but anyway, I'm going to go ahead and write down the domain of this inequality. And it's really more or less, it's effectively just the domain of the left-hand side here. Notice that the left-hand side involves a quotient where the division by 0 is a possibility, right? And so we have to start at minus 1/5. And also notice here we have to exclude 0 from the domain of the quotient there, because if you put 0 right here, you get 1 minus the square root of 1, which is 0, and you'd be dividing by 0, right? So we do have to exclude the value of 0 because it does induce a division by 0. And also we have to, we can't take any numbers to the left of minus 1/5, and that just happens when you set 1 plus 5x greater than or equal to 0. Okay, we want to avoid imaginary complex numbers here. Now, so the entire domain of the expression is this okay, interval notation. It's any real number greater than or equal to minus 1/5. All right, and also it's punctured by 0. We have to exclude 0 as well. So it's the real number line to the right of minus 1/5, essentially excluding 0. Right. Now the goal here, and it's not obvious this is the goal. I had to look at the solution. I would not have known how to do this. We end up doing a U substitution, and we'll express this in terms of U, and it's easier to analyze the inequality in U as it turns out. Not that I would have foreseen this, but after you look at the substitution, you'll believe why it's true. If we choose U to equal to this part of the denominator, U squared, of course, is just equal to 1 plus 5x. All right. Now, if we add 11 to both sides, we already get 5x plus 12 for U squared plus 11, right? So U squared plus 11 will replace 5x plus 12. And in a similar fashion, U squared minus 1 quantity squared will replace 25x squared. And again, that's very easy to see if you subtract 1 and square from right here, okay? So now, the expression, the inequality we were trying to solve, transforms to this expression in terms of U. Now you may think, God, is that easier? And that's what I thought too. But there's a cool thing that happens here that's a little subtle that I did notice for a while. Notice that what's the best way to do this, I suppose? Minus U minus 1. Okay, and you can put the minus sign on either side. It doesn't make any difference because it all works out the same, but equals to 1 minus U, right? Now, apologies if you're going, duh, that's obvious, but it wasn't to me that this happened. You have to look at it just for a minute to, oh, okay, yeah. But you see, minus this is that, and then when you square both of these objects, you see you're actually, when you square this, you get this, and so you get the U minus 1 quantity squares canceling because this minus sign is getting squared too, is basically what's going on, okay? So what happens is all of this stuff just cancels, folks, owing to the fact that when you square the minus sign, it becomes positive, but it also inverts the order of the two terms, right, which gets it in the proper order, okay? Now, so what happens here is we're just left with U plus 1 quantity squared. All of this canceled. Isn't that cool? All of this canceled owing to this truth right here, okay? Now, so what do we get out of this? We get, when you expand this out, you certainly get U squared plus 2U plus 1 equals to the right-hand side, which is U squared plus 11. U squared plus 11. Okay, now the U squareds, you can see, folks, the U squareds definitely canceled. If you subtract 1 from both sides and divide by 2, and y'all, that is supposed to be greater. I'm just like an automaton. I'm so used to working with equalities. That should be greater right there. Now, when you cancel the U squareds and then subtract 1, you get U is greater than 5 here. u is greater than 5. Okay, now if we were just trying to solve the inequality in u, we would be done with the problem, but we're trying to solve the inequality in x, right? And remember the linkage here, u is equal to the square root of 1 plus 5x quantity, right? And so when you square this, let me just write it down and I'll come back up. I think it's no need to talk really here. So you're going to get 1 plus 5x which is u squared, okay, is greater than 5 squared, which is 25. Okay. Again, I hope that makes sense because, again, u, which is a little off the screen up here, is equal to this. You can see when you square u, you just left with 1 plus 5x without the radical. That's why I wrote 1 plus 5x right here. But if you square u, you also have to square 5, and you get this statement right here. Okay. Now, where does that lead us? If you subtract 1 from both sides and divide by 5, you get x is greater than. Now, y'all, what we're doing here, I've subtract 1, which gives you 24, divide by 5, and you get x is greater than 24 over 5. Okay. Now, we wrote the domain of the original expression in interval notation. If you write this in interval notation, it's just 24 over 5. Parentheses means to exclude the endpoint. So you have 24 over 5. And then comma infinity. Infinity being the supremum for all the real numbers. Not a number, but a concept, right? Okay, so there we go. And that is our solution. Now, again, just since I did spend some time at the beginning of the problem, both of them, either way you want to represent it, but notice that our domain, based on analysis of the left-hand side, told us it's any number greater than -5, not including 0, okay? Any number greater than -1/5, excuse me, any number greater than -1/5, excluding 0, and this interval certainly lies within those constraints, okay? So again, that falls in there, and that is our answer. And I think I finally got this thing right. Hope you enjoyed it.